All right, so for today, we're actually doing some geometry. Complementary. Now, complementary, whenever we have a right triangle, I've already gone over this once before. When I have a right triangle, I have the two angles that are not this one right here. These two angles together have to add up to what? 90, right? So they're going to be complementary to each other. Okay? So right here it says... Grabbing my notes. Oh, there it is. Okay. So, we have sine A is equal to cosine B. Cosine A is equal to sine B. Okay, this is true for all right angles. For example, triangle ABC. ABC right here. Okay. For sine A, what is sine A going to be? Sine of A. Give me the whole thing. Okay, let's start here. Start here. A is my reference angle, right? You guys all pay attention. A is the reference angle, so let's go through and label everything. This side over here is opposite. Label that. This side over here is this side over here is. So, sine. From my notes, sine, let's go back over the mnemonic on this one. Okay, write it on the top of your paper. If you write it all the time, it will help you practice this one. Okay, so what is the mnemonic for this one? Some old hippie caught another hippie tripping on acid. There we go.
Oh my god.
Where have you been?
Not here.
Hey, okay. So it's not the first time, so.
Wait, did you guys do this on Friday? Because if it was on Friday, I didn't do it.
Yeah, you did
Okay,
this on Friday.
anyway. Alright, so, sine. Come on, it's an old joke. Okay, sine. Sine is what over what?
Opposite over hypotenuse.
Very good. Opposite over hypotenuse. So sine, if I'm looking for sine. So my opposite is A. My hypotenuse is? Very good. So it's A over C. And the cosine of B. Okay, so now I'm going to do, from B, I'm going to do the cosine of B. Okay, so B, I'm going to do this one in green now. So this one, so from B, this side over here is the opposite. This side is still hypotenuse. This side over here is? Okay, so now green. Now I'm dealing with the green one. So cosine is adjacent over hypotenuse. So from green, what is adjacent over hypotenuse?
A over A.
From right here, adjacent, it's going to be, right? So it's A over?
C.
Yep, it's A over C. Okay, so it's A over C for that one. So they're both the same. Okay? So, right here, so the cosine of A, so now let's go back to blue. The cosine of A. So cosine of A, cosine is adjacent over hypotenuse. So from A, that's going to be what? B over C. And the sine of B. So that's going back to green. Okay? Sine of B, opposite over hypotenuse. So in green, that's going to be B over C. Very good. You notice the pattern works out all the time. It's true because A and B are both complementary. Complementary. Okay, so now let's take a look at this next one right here. So on this next problem, it says given triangle LMN. LMN. And the following trig ratios, find the missing side lengths. Okay. Cosine. So from L. So that means L is my reference angle, right? Okay. So from L, I know that cosine is going to be 3 over 5. Okay, let's go with that one.
Wait, how do you know that?
Because it says that right there.
Oh, it just tells you.
See?
You don't have to prove it.
No, it gives you. Yeah, this is everything's given to you here. So we're gonna start with this. But now I have a problem on this one right here. It says cosine is 3/5, but that really doesn't fit with this, does it? So let's go through and label my sides. This side over here is opposite. This side over here is hypotenuse. Very good. This side over here is. Now, I'm going to show you guys a little trick because on these problems right here, it is different. Okay? There's many different ways to solve this, and I'm going to show you guys how to solve this using similar triangles. So, if I'm going to solve this using similar triangles, I know a couple things here. I know that I'm going to have two triangles. I'm going to have this one, and this is actually one of the test questions, so I'm trying to emphasize this. Here's L, here's N, and here's M. That is my right angle, and I have 18 right here. Okay? L is my reference angle. Now, they're giving me some ratios, so it's a smaller triangle, but it has the same angles. This smaller triangle has the same angles. So this is L, this is N, and this is M. Now, we know cosine. Cosine is what over what? Adjacent over hypotenuse. So if L is this right here, so my adjacent is going to be down here, isn't it? Because I already labeled it over here, didn't I? This two triangles actually go together. They're basically the same thing, it's just this is a smaller version. These are similar to each other. So adjacent over hypotenuse. So what is my hypotenuse value going to be? Say 5.
5.
What is my adjacent value going to be? 3. It's right there. It's 3.
3.
Okay. Sine. Sine is opposite over hypotenuse. So my opposite value is? And my hypotenuse is? Hey, look, it's already there, right? Tangent is opposite over adjacent, right? So, what is the opposite? 4. Adjacent is 3. It all fits there. Okay, did I lose anyone with this?
Not yet.
Wait, let me copy this down.
Yeah, what she said.
So, instead of using trig to solve this, I'm going to use similar triangles. So, if you do this, it works out every single time. So, what is the length of MN? So, I'm looking to solve for this one right here. This is my MN that I'm looking for. So, I'm going to put an X right here. Because I want to. So, if I'm looking for this value right here, we have to set up cross products to be able to solve for this. How would I set up the cross products?
3 over 18 over
3 over 18, very good.
and 4 over x.
4 over x. Does that make sense? Okay. If you would have did 18 over 3, you would have had x over 4 as your second part, right? Let's do that cross products. X equals what?
72. Oh, wait,
72,
3x
all right.
equals 78. Or
3x equals,
72.
divide by 3,
24.
x is 24. Oh, hey, look, that was my MN I was looking for, right? So there's my 24. Make sense? Now, it also says find the length of LM. LM is this piece right here. Let's put in a variable so I can solve for that. I'm going to put a Z because I want to put a Z. I like Z. Now, we're going to do cross products again. we're going to do cross products again, and now we're going to solve for this one because it's looking for LM. How would I do that one? 3 over 18 equals 5 over z. Very good. It's not hard, right? Like I said, this is a test question. It's almost exactly like this, but still. Cross products.
It's 30.
Say 3z
I just gave you this one.
equals what? Divide by 3?
30.
Está muy fácil.
You did exactly what my mom does in army. Yeah, it's pretty easy.
Question? I wasn't ignoring you. I was trying to jump. Chris, I heard you.
I know you.
I was doing the steps, though.
Okay.
Questions? Yeah. Not bad, right? Okay, you guys, let's move on to the next one. So, this next one right here says, write sine 32 in terms of cosine. So, if A is 32, so I'm going to draw a little triangle here, just so you guys can see this as an example. You guys could use the paper underneath. You know, someone's borrowing my notebook right now, so I really can't. So if it was, let's say A is here, B is here, C is here. So we said A is 32 degrees, right? Okay. If A is 32, then to get B, I know that it would be, because these two together are complementary, it would be 90 minus 32, right? So that means that A is going to, or I'm sorry, B is going to be what? 58 degrees. Yes? Okay, so now we're going to do this in the calculator. We're going to do this part right here in the calculator. So now, on your calculator, you might have a bunch of crazy stuff in there.
Yeah, you're right.
So, when you pick up the calculator, what do you got to do? Check it's in degrees, and then to clear it off, you do doc B, right? Doc B clears off everything. Okay, what's the sine of 32 degrees? Trig, sine 32 degrees. 0.53. Let's say 0.53.
Wait, slow down.
Okay, now let's try the other one. So what angle goes here? There's my 58 here, right? Okay, there's my 58 degrees. Now, let's do cosine 58. Oh, hey, look. What do we get there?
A number.
0.53, right? They're the same thing. Because they're going to be complement each other. Okay? So I could say, write 17 cosine in terms of sine. So it would be cosine of 17 degrees is equal to the sine of, what did I write over here? How would I find the other one? 90 minus 17, right? These are complements of each other. So in the end, I know that cosine of 17 degrees is equal to the sine of, what do we get? 73, right? That's a lot of what we're doing today. writing it in terms of its complement. And it works because they are complementary. Okay, so now we're going to get some equations to go along with this too. Now, see this right here? There's an equal sign. So I'm telling you right now it is equal. Sine and cosine are complements of each other. I know that these two, since they're complementary, the angles have to do what? Add up to? Very good. That's what I'm looking for. So because of this, I know that this one and this one equals 90. So I'm going to write that out. X plus 4 plus 3x plus 2 equals 90. Now, let's combine like terms. How many x's do we have there? 4x plus what? 6 equals 90. Now I can go through and start solving. So subtract 6 from both sides, right? 4x is how much? 84. Divide by 4.
21.
X is 21. Is that pretty easy? Okay, so now, same thing. There's an equal sign here, right? Sine and cosine, they're complements of each other. So, I would set this one up the same way. X minus 20 plus 2x plus 5 all equals 90. Very good. How many x's? 3x plus 25?
No, minus 15.
Minus 15. Because I have a negative 20 and a positive 5, right? Equals 90. Add 15 to both sides. So 3x is 105. Right? Divide by 3. X is going to be 35. It's not bad, right? Okay, so let's take a look at our practice then. Our practice goes along with these. So, if you're looking at your practice right here for the first two, okay, what do I recommend you do for these first two?
Right, our adjacent.
And how did I do this one? Draw another triangle, right?
Yeah.
You got to draw another triangle to make them similar. Okay, you have to set up your similar triangle first. Okay, trigonomic function of its complement. So, how would I do this one? Is equal, nope. You're writing it as its complement. What's the complement of sine? Cosine, so it's going to be the cosine of, come on, it's on your notes. 90 minus 23. It's right there in your notes. Okay, same thing in terms of the other one, of its complement. That's what it's asking for. And then you still have to finish that one. Okay, and these ones right here, you're going to solve for x. Questions? All right. Don't forget, like and subscribe, right?